Imagine a normal Tuesday night. You're outside. Everything feels ordinary. But then, the sky starts to change.
The stars. They're moving. Not slowly, but like the entire universe just shifted its position. And then you feel it. The ground beneath your feet is no longer stable.
Something massive has arrived, with the gravity of 1,000,000 suns.
And Earth just crossed the point of no return. What happens next is something no life was ever meant to witness.
Okay, first things first. Could Earth actually fall into a black hole? The honest answer is no. Almost certainly not.
Not anytime soon. Not in our lifetime. Not even in the next billions of years. Because black holes are not cosmic vacuum cleaners. That's a myth. A very popular one, but still a myth.
If the sun was replaced by a black hole of the same mass, Earth would still orbit normally. Same path, same speed. Nothing dramatic would happen to Earth's orbit. We'd lose the heat and light and slowly freeze in complete darkness. Because a black hole doesn't suck things in like a vacuum. It simply sits there with extreme gravity.
It only pulls objects in if they come too close. Very, very close. And space is so vast that the chance of a black hole just wandering into our neighborhood is extremely low. But not zero, because there could be millions of hidden black holes drifting silently through our galaxy. And we can't see them. Not directly. They don't shine, they don't glow. So, while the probability is very low, it is not exactly zero.
And that small possibility is enough to make astrophysicists think deeply. You wouldn't see the black hole. That's the terrifying part. It's pitch black. No light escapes it. No glow, no warning beacon. It is the most invisible thing in the universe, but you'd feel it long before it arrived. The first sign would be the tides. Not little beach tides. We're talking tides that would make the ocean rise and fall by hundreds of meters. Because even from a distance, the gravitational pull of an approaching black hole would start dragging at Earth unevenly.
The side facing the black hole pulled harder. The opposite side left slightly behind. And that difference in pull, that's what creates the chaos.
Seismologists would start reporting earthquakes they couldn't explain, volcanoes firing up in places that have been quiet for centuries, the oceans sloshing, the atmosphere disturbed, every GPS satellite drifting slightly off.
Scientists would know something was wrong, and then someone would do the math, and they'd figure out what was coming.
And then, well, there's not much you do with that information. Because unlike an asteroid, you cannot blow up a black hole.
You cannot redirect it. You cannot negotiate with it. It simply doesn't care. Stage 1. The tides go insane. We already talked about this, but now it escalates. The oceans would pile up on one side of the planet. Tsunamis not measured in meters, but in kilometers. Flooding entire continents. Then the earthquakes, the crust of the earth cracking, splitting. Imagine magma pushing up through every fault line simultaneously. Every volcano, every quake, every flood at the same time.
That is stage 1.
Stage 2, Earth starts to stretch. This is the part with the very scientific name.
Spaghettification. Yes, that is the actual term physicists use. Because that's exactly what happens. The planet begins to stretch, like taffy, like dough being pulled apart. The Earth elongates. It thins in the middle. No rock, no iron core can resist it. Earth doesn't just break. It unravels.
like a ball of yarn pulled into a single thread. If you were watching from a safe distance in space, you wouldn't see destruction. You'd see something completely different. You'd see Earth slow down. As it nears the event horizon, time itself appears to slow. Not figuratively, literally. Clocks on Earth would tick slower and slower. Gravity warps time. Einstein told us this in 1915, and he was right. Earth would appear to creep toward the event horizon, slower and slower, its light fading, shifting red, and then almost frozen. Like a photograph, like Earth just paused and never crossed. But from Earth's perspective, everything is normal. Two realities, same event, two totally different experiences of time.
This is not science fiction. This is Einstein's universe.
Reality depends on where you are and how gravity bends time around you.
Earth gets spaghettified. It unravels completely.
Every atom, every ocean, every mountain, every living thing gets stretched into a long, thin stream of particles spiraling inward. And then the question becomes, where does it go? At the singularity, density becomes infinite.
When density becomes infinite, the equations stop working.
General relativity breaks down there. Quantum mechanics breaks down there. The two best theories humans have ever devised both fail at the same point.
The center of a black hole is where everything we know stops being useful. So what happens to all that matter? We don't know, and that is one of the biggest open questions in all of physics. But wait, it gets stranger. There's a problem, a genuinely maddening one. It's called the black hole information paradox. In physics, information is never truly destroyed. Burn a piece of paper. The information still exists in smoke, ash, heat. But black holes seem to break that rule. Everything that falls in seems to just vanish. Hawking radiation suggests black holes slowly evaporate.
But does the information come back out? Or is it gone forever?
Stephen Hawking wrestled with this for decades. Even today, the smartest physicists still disagree. Because if information is destroyed, physics itself may be incomplete. Or maybe it isn't destroyed at all. Maybe everything is stored on the black hole's surface, like a cosmic hard drive. This is called the holographic principle. A flat surface holding an entire three-dimensional universe. It might be the most profound idea in physics, and it's still unsolved. So here's where we land. If Earth fell into a black hole, it would be unraveled, stretched to atoms, consumed by the singularity, gone.
At least from the outside, watching.
But maybe a record still remains on the event horizon. Every city, every face, every memory, compressed into information. Humanity as a hologram. Now, what if something comes out of a black hole? What if there's a reverse, a white hole? An exit where everything gets expelled into a new universe? That's a story for another What If.